In question number 8, we need to figure out what the antiderivative of this integral here is. It's an indefinite integral. And I'm seeing a few things here. One of the things I'm seeing is this 10. This 10 can just be brought out to the front. So we can just bring that out right here if we want. And then I'll have 1 over. And then in the bottom, I need to make this look like this. The square root of, let's see here, I'm going to want 1 minus something squared. And if I've got that entire integrand, oops, if I got that entire integrand that looks like this, then our antiderivative, or the function that has a derivative of that expression, is going to be the inverse sine. And we can also see that here with b, c, and d, that we have the inverse sine. So that's the goal. The goal is to get something that looks like that. How we're going to do that is we're going to have to complete the square. I don't like dealing with this negative coefficient right here. So what I'm going to do underneath the entire radical is I'm going to factor a -4 out. And then I'll have x squared minus 2x dx, of course, keep that differential in there. Now, what I can do is I can try to complete the square in that denominator. So I'm going to keep that -4 hanging out right there. And then I'm going to have x squared minus 2x, and then I need half of -2 squared, which is 1. But I can't just go adding 1 down in the denominator. I have to do something to offset that. Remember that you're actually adding a -4 here, or -4 times 1. So I'm going to add 4 all underneath the radical. If you distributed the -4 to each term, and then combined like terms, you'd wind up right back at the original problem. It's a good double check if you'd like to do that. We'd have -4x squared, 8x, -4 plus 4 would be 0. So that does work out. We'll bring it down to the next line right here. And we'll see what more we can do with this one, because we're not quite set up, and it kind of looks a little bit overcomplicated right now, but just trust me, you'll see how this works out here soon. So I'll keep my -4 here, and then I can change this into x minus 1 squared. Once again, I'm doing that because I need to get something squared there in the denominator. And then I'm going to have a, let's see, I'll have a +4 there on the right-hand side. There's probably other ways of doing this, but this is just my take on it. Oops, I forgot the 10 as well. So we'll put the 10 out front. Don't forget about that. And now what I'm going to do in the denominator is I'm going to factor out a 4. So I'm going to wind up with this. I'm going to have a 4 here. I'll have the opposite of x minus 1 squared. And then I'll have +1. That's also good for us. We want that something squared plus 1, or in this case, 1 minus something squared. And if we continue to work with this one, I'm going to have 10 on the outside still, keep that coefficient. I'll have 1 over. Now then the square root of 4 here, that's this piece. We can actually do that, and we're allowed to break up multiplication between two factors underneath the radical. So the square root of 4 is 2. And then underneath here, and I'm going to rearrange the 1 and then the negative x minus 1 squared. So I'll put the 1 here minus x minus 1 squared. Outside, I can do 10 divided by 2, which is 5. And then I'll have 1 over the square root of 1 minus, now we have that something squared here, dx, and that's exactly what we wanted to see. So I know then that the antiderivative of the integrand, which is right here, that's going to be the inverse sine of whatever that is, and then plus c. That happens to be an x minus 1, so we'll keep that x minus 1 here. And I do want to double check this to make sure that I don't need to use the offset the chain rule. So the derivative of x minus 1 is 1. And if I did find the derivative here, I would wind up right back at the dashed in circled part right here, which is the integrand. If you're struggling with that, you could make u equal x minus 1 and then go from there. However, it looks like we've found our answer. So if we take a look at the correct answer choice here, it appears to be choice C. There's a -2 and a 2 hanging out here, and that should just be a 1, so that's why this one's wrong. And then over here, we have a +1. That should actually be a -1, so this one's not right. And this one doesn't even have an inverse sign in it, so it can't be right either. And if you found the derivative of each one of these, A, B, C, and D, only C would match our original integrand right here.